Hello, class. Today I am going to do a video for the lab, just a little tutorial for the lab. And this was as a request from one of the students. Anytime that you want me to do an extra tutorial video, please just send me an email, text me, let me know, right? So today's lab is on models. Okay, so you're going to be doing models, you're going to be doing Lewis structures, you're also going to be doing some naming of compounds. For this particular lab, just to give you a heads up, there are a lot of pages for this one, right? So there's a lot of work that you need to do for this lab. It's not difficult, but it is time consuming. So I would strongly urge that you make sure that you have plenty of time to work through each of these pages and go through all these problems. But I assure you that after you've completed this, you have a really good understanding of naming compounds, writing chemical formulas, drawing structures, because there's so many examples. And I always say that the best way to learn chemistry is through doing multiple examples. And so I'm going to go through not the naming or the writing formula portion of this lab, but I do want to go through the structures and doing the Lewis structures. So I've picked out a few of them that I'm gonna go over with you just to give you kind of a heads up and also build the model. In your model kit, it's what looks like this, and your, excuse me, your information that you received in the mail for your lab kit. And inside there's this insert front and back, and it gives you a heads up of the different colors for the different pieces that are part of this kit, just to give you a heads up of what goes with what or what represents what. But I'm gonna go through a few of these. I'm starting on page 6. And the first one that I'm gonna go over is CO2. All right. Hopefully you can see my whiteboard here. So CO2 we're gonna do, and the first box, it says to do this crude sketch. So when you're doing the crude sketch for each of these, you always want to put your central element in the middle. And to know which one is the center, it's always the first element listed unless hydrogen is listed first. Then in that case, it's the second element listed. So in this case, C is listed first, and so it goes in the center. And then we have 2 oxygen on that are connected to the carbon. All right. Remember, C is carbon, O is oxygen. And where you place the oxygen, totally up to you, right? I like to put them on either side just to show the symmetry. But you're going to imagine that you have a square box around the carbon, and then you have 4 sides to the carbon. And so the elements can be placed on any of the 4 sides, right? So the next box, it says calculation, number of valence electrons and number of bonds. And so, first of all, the valence electrons, the way that I like to do it is I like to go through each element and figure out the valence electrons for each element and then add them all up. And so carbon, because it is in group 4A in the periodic table, has 4 valence electrons, all right? And all your main group elements, the group number tells you the number of valence electrons. Your main groups are your A group elements. So if you look in your periodic table, if you look at the top of the column, you have 1A, 2A, 3A, 4A, and so forth, all the way up to 8A. That group number tells you the number of valence electrons. For oxygen, we have 2 oxygen, all right? So we need to do 2 times, and oxygen is in group 6A, And so it has 6 valence electrons. So we put 6 electrons here. All right, so now we want to know the total number of electrons. So we have 4 electrons from carbon. We have 2 times 6 electrons from oxygen. So we know that 2 times 6 is 12. And if we add 4 to that, we get 16 electrons, okay? So that's the total number of electrons that we have to work with to draw our structure, right? The next thing we want to do in this same box is we want to subtract the number of bonds. And so we have 2 bonds here. Each bond represents 2 electrons, all right? So the way that we have it is we have 16 electrons total. And then we're going to subtract our 2 bonds. And we have to multiply that by our 2 electrons. All right. So 2 times 2 is going to give us 4. 16 minus 4, this is equal to 12. All right. And so our first 2 boxes we have, so this will be our first box. This is our second box. Okay. For our third box, we're going to draw the Lewis structure. All right. And so to draw the Lewis structure, you're going to take your crude sketch, which is step number 1, and we're going to add electrons around the elements so that we obey the octet rule. Remember that the octet rule means 8. And so we have this structure. All right. So we have 12 electrons that we have left that we're working with. We want the elements that are connected to the central element to obey the octet rule. We work with the central element last. It makes it a lot easier. All right. So I'm going to make these dots a little more pronounced just so that you can see them. I don't want you to miss them, but they're not really dashes. That looks like a mess. Let's make that a little bit. Let's make that a little bit better looking. Try using a thicker pen. All right, let's see. There we go. That way you can see the dots. They don't look like dashes. I want them to look like dots. All right, so we're gonna put our dots around our oxygen. And remember, we're obeying the octet rule, meaning 8. We already have 2 electrons for the bond, and we need 6 more electrons, and we put the dots as pairs. Okay? And remember, we're thinking of this box that's around our element, and so we have 4 sides on a box. So we're going to put our dots and our dashes within those 4 sides. We do the same thing for the other oxygen. So the dots, remember, represent the electrons that are called the lone pair of electrons. And then the electrons in the dash that connects the 2 elements, those are our bonding electrons. That's going to become important when we're looking at the shape, right? So now the next thing we want to do is we want to see how many electrons we've used to obey the octet rule for oxygen. So we use 6 on this oxygen and 6 on here. So that's a total of 12. So we've used all the remaining electrons, all right? We've used all those. But if we look at our structure, we see that carbon only has 4 electrons around it. It has not obeyed the octet rule, and we wanted to, right? And so how do we do this? And so in order to do this, we need to share some of the electrons from oxygen with carbon. And we're going to do that on both sides. So we're going to share 2 electrons here. We're going to share it and take 2 electrons from here. And we're going to share it because we need a total of 4 electrons, right? So when we do this, our new structure becomes carbon with a double bond to oxygen and a double bond to the other oxygen. And we have still our electrons that we had left around our oxygen. Okay? So this is now our new structure. This is the third box, our Lewis structure. Okay. So the next thing we want to do in box number 4 is the number of electron groups and the electron group geometry. So if you look on page is not numbered. Okay, 1, 2. It looks like the third page, excuse me, of the experiment doesn't have a number on it, but it is, see if I can bring this up so you can see it. You can see it, but it's that chart. Okay, so the chart's what we're looking for. And so to find the number of electron groups, we are going to count the groups that are around the central element only. Okay, we're only looking at what's going on with the central element. And so we count the double bonds as one complete group. All right, so this is one group. This is 2 groups, okay? So there's 2 groups around it. All right? And so I want to, I'm gonna clear my board. All right, because we got a lot going on here, and I want to make it plain what I am doing. I'm going to clear my board. Got a lot going on this board. Okay, let's try this again. All right, so I'm going to redraw my structure so that we have that. And we established, before I cleared the board, that we had 2 electron groups, okay? So the number of electron groups is 2. And if you look in that chart, for 2 electron groups, it is linear. All right. Then the next box says the number of bonded atoms. So the number of bonded atoms is also 2. And that would still be linear. All right, for linear, the electron geometry and the molecular shape are always going to be the same. It may change for the other ones, which we may see in our next examples. All right. So now the resonance structures. When we're talking about resonance, and I'm going to point you to the area where it talks about resonance structures. So in part C, it gives you a little information about resonance structures and how the molecules can be drawn with resonance. basically, when we're looking at resonance structures, it deals with how we move the electrons from one particular version of that compound structure to another. And so we can move our electrons, okay, for this particular structure. And so we could move the electrons so that they are on, you're gonna have 3 bonds on one side and a single bond on the other side, or 3 bonds on this side and a single bond on the other side. And so we would have essentially 3 different structures that would be in resonance, okay? And so I'm going to draw our main structure in the middle. I think I'm gonna erase these just so that I have plenty of room. All right. All right. Okay, there we go. And so I'm drawing a little small just so that I can make sure I have plenty of space and widen my whiteboard a little bit more. All right, so we have the one that we drew originally. That's gonna go, I'm gonna put that in the middle. And then we have one where we have a triple bond with oxygen. And in that case, we would only have 1 lone pair of electrons, and a single bond with oxygen, which in that case, we have all of our valence electrons. And in between these 2 structures, you're gonna draw a double arrow, okay? All right, and then the other one would be here, where we would have a single bond with carbon and a triple bond to this oxygen. Okay, and then we could draw our electrons still there. All right, so those are our resonance structures. Each time we're just moving electrons around. So in one case, we're sharing two pair of electrons with the carbon and 2 extra pair of electrons. This one is keeping all 6 of its lone pair of electrons, and the other one is vice versa. Okay, so those are your resonance structures. And then the last box is polarity. Okay, with polarity, again, it's part D, it explains it. There's some criteria that have to be met when we're talking about polarity. With polarity, a molecule is nonpolar only if it has no lone pair of electrons about the central atom and all groups attached to the central atom are identical. So both have to be met in order for this particular molecule to be nonpolar. So let's look at the first criteria. No lone pair of electrons on the carbon. So as you can see, there are no lone pair of electrons around the carbon. The next thing is that all groups attached to the central element are identical, meaning that they are the same element. So you can see they're both oxygen. So both criteria have been met. And so we say that this molecule is nonpolar. Okay. All right, so that's it for that first example. And as you're going through this video, if you have questions, please jot them down and then let me know that you have questions. Send me a text or send me an email, however you want to notify me that you have questions, all right? And let me know. All right. So now we are going to erase this and go to the next example. All right. Our next example is SO4. We're going to be doing SO4, and it is 2 minus, and that is a 4, but it definitely doesn't look like 1. So let's try it again. There we go. SO4. All right. And so with SO4, remember the first element listed, unless it's hydrogen, is always going to be your central element. And so we are going to do our crude sketch. I'm going to try to make this nice and concise so that I can try to fit all the information without erasing it. All right. I'm going to try to be a little bit more organized here. All right, so that's our crude sketch for SO4. The next thing we're going to do is the number of valence electrons. So sulfur is in group 6, so it is 6 electrons, then 6A. Oxygen is also in group 6A, and there are 4 of them. So it's 4, times 6 electrons. And then we have this -2 charge. When we have a -2 charge, you add the electrons according to the charge. So if it's negative, you want to add 2 electrons. If it is positive, you want to subtract the number of electrons. Okay? So we are going to add this up first. So this is 4 times 6, which is 24, plus 6, which is 30. So we have 30 electrons. And remember, we want to add 2 electrons for the charge. So we have a total of 32 electrons. Okay. We have 4 bonds here. All right, so we're going to take our 32 electrons and we're going to subtract 4 times 2 electrons. Because remember, each bond represents 2 electrons. All right, so it's 32 minus 8. And so we have 24 electrons that are left. All right. So the next thing we want to do is we want to add electron to our structure to give us our Lewis structure. So I'm going to actually add it to our crude sketch here. And so 24 electrons, and we know that each oxygen wants 6 more electrons, the same like we saw in the previous example. So we're going to put those 6 electrons, and remember, we put the dots as pairs, and we're imagining the 4 sides around the element. And that's how we're going to place our Lewis structure, our Lewis dots on our oxygen. Okay. So we've used all 24. So now we want to check. That should be a check mark. That looks a little crazy. All right, let's try that again. All right, so we've used all 24. Now we want to check to make sure that sulfur has 8 around it as well. So we have 2, 4, 6, 8. Sulfur is perfectly happy. The last thing we want to do is, because we have a charge on this structure, we need to put square brackets around it and then put the charge on the outside of the square brackets. That's to let us know that 2 of those electrons that are in here are based on the fact that we have that -2 charge. Okay. So the next thing we want to do is the number of electron groups. So we have 4 groups around it. And if we look at our chart, 4 groups would be tetrahedral. All right, that's for our electron geometry. So we would write tetrahedral. Okay. If we look at the bonded groups for the molecular shape, the only way the molecular shape changes is if we have a lone pair of electrons on the central element, but we don't. So in this case, all of our groups are bonded, and so that would also be tetrahedral. Okay. All right. So the next thing is our resonance. When we're looking at resonance, just to give you a heads up, if you have lone pair of electrons on the central element, or if you have double or triple bonds present in the structure, then there's a possibility for resonance. But since that's not the case for our structure, there's no resonance. So you would say none in that box for resonance. All right, and then the last thing is if it's polar or nonpolar. Remember our 2 criteria for it being nonpolar. 1, no lone pair of electrons on the central element, which as you can see, we don't have any. And 2, that it's bonded to all of the same element. And so we see that it's bonded to only oxygen, no lone pair of electrons. And so since it meets both criteria, it would be nonpolar. All right, and that's it for that example. All right. So we're gonna do a couple more examples just to get you familiar with it, with what we're doing. Let's switch that up. I'm gonna do that one instead. So I'll show you the form. Okay. All right. So our next example is PF3. So let's get a fresh board. All right. So for PF3, that's what we're going to do next. So we have P, which is phosphorus, and we have 3 fluorine, F is fluorine, that are attached to it. And this is our crude sketch. All right. The next is electrons. So we have phosphorus, which is in group 5A. So it has 5 electrons. We have fluorine, which is in group 7A, and we have 3 of them. I don't know why that's staying up there, but anyway, 3 times, and it's 7A is the group, so 7 electrons. All right, so we have 3 times 7, which is 21, plus 5, which gives us 26 electrons. Okay. And so we're going to take the 26 electrons and we're going to subtract our bonds. We have 3 bonds. And remember, 2 electrons for each bond. And we get 20 electrons left over. Okay. So the next thing we want to do is we want to make sure that fluorine has its 6 electrons around it, just like we did for oxygen in the previous 2 examples. We do the same thing for fluorine. Okay, when we do that, we've used up 18 electrons. Okay, in the previous 2 examples, we used up all of our electrons, but in this case, we used only 18, so we have 2 left. And so anytime you have leftovers, they go on the central element. Okay, let me erase some of these floating dots everywhere. Okay. All right, so this is our Lewis structure. So the next thing we want to do is the number of electron groups. So we have, when we talk about electron groups, to this point, we've only dealt with bonds. And so now we have bonds and lone pairs on the central element. The lone pairs, each pair counts as 1 group. And so we have 1, 2, 3, 4 groups. And so we have 4 groups around it. And so our electron group geometry would be tetrahedral. Okay. For our molecular geometry now, it asks how many bonded atoms. So we only have 3 bonded atoms, all right? So bound to something else. So if we look on the chart, if we have 4 electron groups, 3 bonded atoms, then our molecular shape is trigonal pyramidal. All right. Ooh, that was bad writing, but you see what I'm trying to say. All right, so for the resonance now, for resonance, if we look at this, because the fluorine have obeyed the octet rule, we don't want to move around the electrons to change that. And so for resonance, this would be none. Okay. The next thing we look at is polar. So remember, there's 2 criteria for nonpolar. It has to have the same element that it's connected to and no lone pairs. But here we have lone pairs on our central element. And so because of that, that makes this molecule polar. All right. And that's it for that example. All right, so we're going to do one last example. And that would be NH4. So we're going to add another sheet. A lot faster than erasing all this. All right, so we're doing NH4 plus. All right. Again, Our nitrogen is listed first, and so that's going to be our central element. So we have nitrogen, and then we have 4 hydrogen that are attached to the nitrogen. Okay. And so now we're going to look at our electrons, our valence electrons. So for nitrogen, it's in group 5A. So it has 5 electrons. For hydrogen, there are 4 of them. And each hydrogen has 1 valence electron because it is in group 1A. And that's all squished together. Let's kind of separate that a bit. All right. So 4 electrons, 4 times 1 electron is 4, plus 5 will give us 9 electrons. But we have a charge that's here. This charge is positive. Remember, electrons have a negative charge. So anytime it's positive, that means we're going to subtract electrons. And when it's positive, there is this 1 that's understood. You don't have to write it. There we go. You don't have to write it, but just note that that is what that represents. And so we're going to subtract 1 electron here. And when we do that, we have 8 electrons that we are working with. All right. The next thing we want to do is we want to subtract the number of bonds from our 8. So we have our 8 electrons, and we're subtracting, we have 4 bonds. And remember, each bond is 2 electrons. So 4 times 2 gives us 8. 8 minus 8, we have 0 electrons left. All right, but wait a minute. If we look at our structure, we don't have any electrons to put around the hydrogen. This is one of the exceptions to the octet rule. Hydrogen obeys what is known as the duet rule. And let me look and see if they talk about the duet rule in your information. And I see that it really doesn't. Talks about the octet, and it may talk about it. I'll just tell you what it is because I don't see it. But when we talk about the duet rule means that there are elements that are perfectly stable with just 2 electrons, okay? And let me go back a little bit for the octet rule. The reason for the octet rule is if we look at the elements in group 8A, okay, those are the noble gases, they have 8 valence electrons, and they are the most stable elements in the periodic table. The other elements want to obey the octet rule because they want to become stable, okay? So the purpose of this is for stability. If we look at helium, helium is in group 8A, it's a noble gas, but it only has 2 electrons. And that is why we have the duet rule, because of helium being perfectly stable with just 2 of its electrons. Hydrogen, because it's on the same row as helium, the same row in the periodic table, it also is perfectly stable with just 2 electrons. So it doesn't want dots around it to get to 8. So the bond that represents the 2 electrons gives hydrogen its stability, okay? So be careful of that when you're drawing your structures. Don't put extra dots around hydrogen. It only wants the bond. And so we have 2, 4, 6, 8 around nitrogen. And so it's obeyed the octet rule. And so this is our final structure. The one thing that we need to add to this is that square brackets. Remember, we saw that previously when we looked at another example that had a charge. And then we put the charge on the outside of the square brackets. Okay? And so that is all for, oh, sorry, I haven't finished it. I was wrapping up and I wasn't finished with this one. All right, so let's finish it. So this is our Lewis structure. So now we're looking at electron groups and we have 4. So our electron geometry is tetrahedral. Okay. And then our bonding groups is also 4. And so our electron shape is also tetrahedral. I'm sorry, our molecular shape is tetrahedral. All right. And we have no resonance. So I'm going to put none for resonance. We don't have any double bonds that can be shifted around. And then for our polarity, this is nonpolar. And remember, it's because it's bonded to all the same element. And there are no lone pairs around the nitrogen. All right. So now I can say this is the end of this tutorial. If you have questions though on any of the information for this particular lab, then please let me know, okay? Your portion that you're actually going to turn in starts on page 6, all right? And you're gonna do pages 6 through 17, okay? Remember I said it's a lot of information. So because it's so much information, make sure that you allow yourself plenty of time to get this lab completed and turned in on time. If you have any questions, let me know.